All right, welcome everyone. I have a tradition that that this has to work in order to. I got a tradition, as I was saying, and I have my Zoom window in the middle here. There you go. Okay, cool. Let's take a first conference selfie after so long. Say hi, hello. That's cool. This was the sad reality of the other conferences where I was home to take these selfies. Okay. So let's talk about testing OTP. I'm Andrea. I'm a member of the Elixir core team. I've been for the past 6 years, 5 years, something like that. I work at a company called Community. I'm a principal engineer there. Our company does communication at scale. So we give tools to celebrities and companies to talk to the communities of fans that like them, basically. We are hiring, so you can go to community.com/careers, and you're gonna find all our positions. We have a bunch of engineering positions over there too. Then I wrote a book, which is not why I'm here, not trying to promote the book at all. And I wrote this book with another guy who is not here. I should have been, but it's from the US and it's not super easy to travel, so he's just gonna not be here. This is the book called Testing Elixir from Prague. You can go buy it on the website. Okay, so let's talk about testing asynchronous OTP. I've talked about this in the book. It's a part of the book. I think it's one of the most interesting things. The book is about testing Elixir in general. So we test, we talk about unit testing in Elixir, about integration testing, end-to-end testing, testing Ecto, testing Phoenix, doing some property-based testing. But I think that a lot of those are pretty generic testing concepts. And so we talk a lot about the tools. But when it comes to testing OTP and testing asynchronous code in general, I think there's a lot to learn from just the concepts of testing, and not just specifically about Elixir and Erlang. So what is hard about testing asynchronous code and testing OTP concepts? The first thing is that asynchronous code is unpredictable. So in general, concurrent and parallel and asynchronous code is unpredictable because it's harder to it's non-deterministic usually, right? Execution is not from a operating system perspective, from a virtual machine perspective, is non-deterministic. So you have a runtime and you have execution that can go in different ways based on a lot of other factors, right? So it's hard to have reliable and easy to write tests that test a lot of these things, a lot of things related to asynchronous and concurrent or parallel code. Another thing that's hard about testing all of this is global resources. So usually when we have this in our OTP applications, it's common to have some resources that are shared by the whole application. So processes in your application supervision tree that are accessed by other different processes. So they're generally some global shared state in the application, and then it becomes hard to test that in isolation, right? So it's hard to change and during testing, and it's hard to test behaviors like this without changing the rest of the application, without interfering with other tests and doing it in isolation. And then it's hard to test in OTP, especially I think it's hard in general, but in OTP too, it's hard to test system failures, right? So it's usually tends to be easier to test the happy path, but we know that the happy path, it just like doesn't happen, right? So there's failures are expected and common, and so it would make sense to test for them, but it's not quite as easy as testing for the happy path. And Erlang and Elixir in particular, there's this "let it crash" slogan, which is a bit hard to come to terms with from the perspective of testing as well, because you say write code in a declarative way, write the happy path and let it crash. I have strong feelings of disagreement with all of that, but if you do that, then still testing is a nightmare, right? Because anything can fail at any point, and what happens to your code, what happens to your system when that happens if you're not testing it somehow, right? And in general with system failures, it's also also, again, hard to keep the failures isolated in the tests and to reproduce them reliably so that they can be tested in an automated way. So so these are the things that I think are hard about testing asynchronous code and testing generally OTP. When I mean OTP, I really mean the Beam and OTP applications. I don't mean particularly abstractions or like gen servers or gen state machines. Those are particular cases of processes that we're testing. So it's not a lot of special about them, but those I think are the hard things to test about all of these. What are the two lessons that I would like to share in this talk? The first one is that a good test is a test that fails. This is my mantra when I write tests, and so I like tests that fail when something is wrong, and that's the #1 priority. Then tests are still part of your code base, so they still need to be nice somehow. They hopefully shouldn't break unnecessarily. So if they don't break if you change something that doesn't change the behavior, that's ideal, but that's a plus. That for me, the baseline is that they need to break if something is wrong, right? So I would rather have tests that break too much than tests that don't break enough. And I like this quote from Joe Armstrong about code, which I think everybody knows here, which is make it work, make it beautiful, make it fast. And then so it's more complex. Make it work, make it beautiful, and then if you still need to make it fast or something like that. But I like to apply this to kind of test design. So the first thing that they need to do, that the test needs to do, is to break if something is wrong, and that's the make it work part. And then you got to make it beautiful, meaning that like it would be ideal if it doesn't break, too much or unnecessarily, and the code is generally nice, and it's isolated and all of that. But that's the make it beautiful part. And the make it fast just stays the same. Fast tests are better than slow tests. So that's the first thing I want to share and communicate. And the other things is that I want to give you some ideas and not recipes. So I will try to cover a bunch of things, but I will do that very superficially. I generally think that a 30-minute talk is really not a viable way of teaching much. It's more of a way of exposing the audience to ideas, so that's what I'll try to do. So my goal is just that you will get out of this room, having some ideas and some food for thought about testing, rather than knowing how to test asynchronous stuff or knowing how to test OTP abstractions. There's a bunch of stuff that I will talk about that where I say what the problem is, and then I don't say the solution because I don't know what the good solution is. So if you actually have good solutions, you will be able to tell me, and I will be very happy. And last but not least, of course, all the recipes are in the book, so you're gonna have to buy the book if you want to know more. Just kidding. The book is also a bunch of ideas. So this talk is also a story of acceptance, because the more we will progress in this talk, the more we will realize kind of what I said before, that a good test is a test that breaks, because we will start with testing things that are a little bit easier to test and a little bit cleaner, and we will keep going and testing harder and harder stuff, and or at least I had to come to terms with the fact that testing hard stuff is hard, and it becomes very dirty very quickly. So we need to all learn to accept that dirty tests are better than no tests, and so on. So we're gonna kind of dig a little bit into the rabbit hole here. We're gonna talk about three main things. First one is testing stateful processes, which is a pretty common thing to do in OTP. Stateful processes are a pretty common element in OTP applications. And then we're going to talk about testing background code, so code that generally runs in the background and kind of not actively interacting with your application, especially during testing. And then we're going to talk about testing resiliency, so testing system failures and how the system handles those. So let's start with testing stateful processes. When I say stateful process, I mean when the state that we're dealing with is in another process, rather than a process that we are. So it's not a data structure, basically. Instead of having pure functional data to work with, we have a process that contains some data somewhere. right? And the example that we have in the book is a rolling average server. So it's essentially a gen server process that holds a list of integers, and it's a rolling list. So you give it a limit, and then you keep adding elements, and when it reaches the limit, if you add more elements, it drops elements at the end, right? So implementation is not very important here because we're focused on testing, but you can imagine it's a pretty straightforward thing to implement, and you can ask it for the average, and it's just going to tell you the average of the rolling average of the list. So this is obviously like it can be implemented as a functional data structure. It probably makes sense to do that. But imagine a scenario where this data structure needs to be shared by a bunch of processes, and so we want to stick it in a gen server that acts as this shared state. And what we want to focus on is that the state is in another process. So the state here is in the gen server process rather than in as a data structure, right? So we're not working with pure data anymore, right? That's kind of the harder part. When we're working with pure data, usually testing is pretty easy because you can see the data. It's just data, right? In Elixir, Erlang data has no behaviors, it's just data structures. You can't, like the number of data structures we have is limited and pretty small too. So it's not, it's pretty easy to work with that. And instead, when you put the state in another process, you're kind of, then that process becomes responsible for managing the data. And so when testing, we need to figure out how to test that in a way that's not pure and functional, right? And the most important thing is that when I have a process that holds state, when I have a pure functional data structure, what happens is that if I change the data structure, I get something, I can't change it, it's immutable, right? So I get something back, and I always have something to work with. Basically, I always have the data structure that I'm manipulating during the test. What happens when I have a test, when I have the state in another process, is that I need to test the changes in the state, but the state is held by the other process, right? So I need to figure out how to test that in a way that's clean and that's reproducible and isolated and that works. So let's start with like a really simple test. So we have a test that we're testing the add function. We're trying to do unit testing, so we test just add the function here. We started a rolling average server. We add a number to that, but now what, right? If this were a data structure, rolling average.add would have to return something. And we could inspect that somehow. It would have to return a list or something like that, or a data structure that would represent this rolling list. But this is a process, so adding is just putting something in the state, right? The process is changing the state, but it's not telling us anything in return, right? So what do I do in this case? Generally, my advice when you have something like this is to use the black box model, and black box model just means don't necessarily inspect how something is implemented, but try to test it don't try to test how something is implemented, but try to test it as a whole. So try to test it the way that you would use it in your code. And in this case, it means, for example, having get and set operations on this state that's exposed by this other process, right? So this test is, this test is a little bit bigger, but it should be pretty simple as well. We do the same thing as before. So we test, add the add function and the average functions together, and that way this is what I mean by black box model, right? We have we're not inspecting the state, we're not inspecting the data structure, but we are testing the behavior of the process that we're working with, right? So we're testing the fact that we can add numbers to it, and it gives us the expected average for those numbers. So we do 2 calls to add, then we assert that the average is right. We do another call. The limit is 2, as you can see in the second line. So we add another number, and we test the rolling behavior, basically that the average shifts up to a higher number since we dropped the first number there. So this is a good, generally like a good principle. It's a very, very simple example, obviously, but it's a good, I think it shows the principle of having kind of get and set functions when you hold a state in another process, and so treat it as a black box as much as possible, and have that process manage the changes in state and test the behavior as a whole, right? Another idea to take out of this that's I think, a lot more applicable, especially when the code becomes more complex, is to have processes that hold state, to split them into functional core and a stateful layer above it, basically. So what do I mean by that is that we would split the data structure as a separate functionality, as separate modules, and have the API on the data structure. In this case, it would be a rolling list, right? It will be a rolling list, which is, I mean, a data structure, pure and functional, and it would have an API on that data structure to add elements and to do the rolling of the list and to calculate the average, and then have a very thin gen server wrapper process on top of it that then we can test more easily because we need to test less. Right, so if we do test the data, if the data structure has a public API, we can test the data structure in isolation. It's usually faster. It's usually easier to work with a pure and functional data structure, and we test the process, the very thin layer of the gen server on top of it with less tests, essentially, and so that makes things a little bit easier and a little bit faster. So what I mean, to show an example, is that we could have like a rolling list module that returns that has a new function, returns the data structure. The data structure is like, in this case, it's a tuple. It could be a struct. It could be whatever we need it to be, really. But this API is pretty simple. You do add and you do average the same way as you would do before with the gen server. But the thing is that this is a pure data structure, right? So, for example, I can write tests for it that can inspect the data structure if I'm good with inspecting the data structure. If I still want to treat it as a black box, I can still do the get and set thing on the data structure itself. That principle applies anyways. But I would feel personally much better if this was if I could inspect a data structure, right? Because in the gen server, I don't want to get the state out of the gen server in order to inspect this, right? So I could write tests like this. I could test things a little bit more in isolation if I wanted to, and generally the tests take less setup, they're faster, and then I would just write a gen server that has that is a little thin wrapper around this data structure, whose state is this data structure, right? And this is a good example of changing the behavior of your code, or changing the architecture of your code to favor tests a bit. And this is one of the perfect examples of how, trying to architect your code towards better testing can make your code just better in general, or like more easier to read and easier to work with. For the cases where you do need to get the gen server state, we actually do have a function to do that. It's called sysgets. I bet most of you know it already. Not a really good thing, in my opinion, to use in tests, but we could use it to do something like this, right? We store the state of the gen server in the gen server without the additional data structure, and then we call rollingaverage.add, and then we can just get the state of the gen server and do assertion on that. That's very much breaks the black box model. So I tend to not recommend to do it ever, if possible. But there are some times where the lengths that you have to go to in order to avoid just looking at the state of a process are really make things very hard and make tests harder to understand, harder to write, harder to maintain, and harder to just slower to run or more brittle. And in those cases, that's exactly what I mean. Part of what I want to transmit in this talk, which is that the important thing about a test to me is that it fails if something is wrong. So then the fact that it shouldn't fail if nothing is wrong is secondary. So I would rather have a test like this that fails if I change implementation, if there's no other way to do it, right? Rather than having a test less tests and having something break because it's not tested, right? Or have no tests fail if I change something that changes the behavior, right? So this is a case where obviously in this case it probably doesn't make sense, but hopefully you get the idea that not a good tool to use all the time, but definitely a tool that I would rather use to create tests than not have tests at all. The other important thing about testing processes that have state, or generally this is testing processes in general, especially OTP behaviors, is that I want to mention is the process life cycle in tests. So in this case, for example, when you saw that in the examples, I was starting the gen server in my tests. I was calling rollingaverage.startLink. And when I do that in our tests, what happens when the test exits? So when the test exits there, the test is a process. And when I call start link and create that gen server is another process, but it's linked to my test process. So that ensures that when the test process exits, the other process exits too. Right. The problem is that when the test process exits, maybe the gen server process that doesn't exit gracefully, right? Maybe it's not trapping exits, maybe it's not implementing, cleanup logic or anything like that, and it doesn't quite get always, or if the test fails, it doesn't get a chance to shut down properly, and instead, so there's no graceful shutdown really, right? And instead, the ExUnit provides something pretty cool for this, which is that you have every test process starts its own supervisor, and the supervisor it's for that specific test, and the supervisor is linked to the test process. And then you have a little function called start_supervised. I will show you in code as well. And this function starts a process under the test supervisor. That way, when the test exits, it sends an exit signal to the supervisor. Supervisor shuts down and shuts it down its children gracefully. Right, so and it giving them time to shut down, as per usual supervisor semantics. So instead of calling rollingaverage.start link here, I would call something like start supervise and pass a child spec. That's what you would do in your application supervisor. And this means that when the test exits, now the rolling average supervisor is shut down gracefully. It gets a shutdown signal from the supervisor. The supervisor gives it time to shut down. Again, in this case, very, very artificial case, because probably there's nothing we want to do. But imagine a case where we want these processes to have some proper cleanup. This is especially important when you have other processes that. So when you have multiple tests that are running, and you want to ensure that when the test finishes, the process exits, is monitored and exits, and it's given time to exit. So before the next test starts, right? So like before we had this, I remember it happened to me quite a lot that I would have multiple tests, and they will all at the beginning would start a process, and then they would overlap because the tests don't overlap themselves, the test processes, like they're executed sequentially. But if the resources that you start in a test are not given time to shut down, then you might have the next test start with the resources still shutting down there, right? And this avoids that because the test waits, when exiting, it waits for the processes that are started under its supervisor to exit. It's just a cool thing about the OTP-specific thing. So this is kind of the simplest part of testing state that's in other processes. My personal nightmare is testing background code, which is generally code that doesn't that you don't interact with, like we were doing here, right? Like we had a process where we were kind of chatting with this process, like adding elements to this rolling average thing and getting the average back. You were interacting with it, right? And we were starting this as a resource in the test and just interacting with it. Sometimes you have background code, right? And by background code, I mean code that you're not interacting with. Super simple example, imagine you have a function, background work, that starts a task and with task.start, so without really waiting for the result, right? And the task does something. And how do I test this function? How do I know when it finishes executing, right? That's the biggest thing. How do I know when it's done? Because you don't, if the code is executing in the background, you don't really have a signal when it's finished, right? It's not a synchronous function call. My favorite technique to deal with this is usually to use message passing somehow. And the general idea is that you have your test process, you have your worker process that's doing the background work, and what you try to do is that you start the worker does the work, and then somehow it sends a message back to the test process. And in the test process, you use assert receive, which is part of ExUnit, to make sure that you get like a kind of a notification back from that process, right? So how could it look like? Imagine that we change this background work function a little bit to take also a parent PID and a ref, and then when it's finished doing its work, it sends a message to the parent bit with that ref. Right. So we're changing the API. It's not ideal, but it makes it kind of sends and broadcasts or sends a notification when it's done. Basically, that's the idea, right? It sends a message when it's done executing. And to test this, then it becomes pretty easy because we just create a ref, we pass the test PID and that ref to the background work function, and then we use assert receive to make sure that that we get a message back. So again, changing the code in this case not ideal, but it gets you. But I hope it shows the idea of message passing in order to make sure to understand when something is finished executing. The good thing about assert receive that I really like is that it's very fast and reliable. So it works well. It looks at the message mailbox. It has as soon as you get a message, the assert receive function is okay with it returns. So it makes tests as fast as they could be. Like in this case, it's basically as soon as the task sends the message, then the execution stops, which is the assert receive stops, which is like as fast as it could be, right? As I said, I'm not a big fan of doing of changing the API to pass PIDs and references around just for the sake of testing. So what I like to do is that usually when you do this kind of background work, you're interacting with some other system or doing some I/O or doing some side effects. And usually when I have something like that, I like to do it behind an interface. So if I'm interacting with some external system or something like that, it's behind an interface. If I have an interface in my code to an external system, it probably has test doubles because it usually is not reliable to have this is like integration testing concepts, right? It's not great to have dependencies on external systems to run your test suite. So usually we try to do something like using mocks or stubs or generally test doubles. And usually you have that. So what I like to imagine that here the background work is posting a tweet. In this case, I would have something like Twitter module.post, and the Twitter module could be in the test. It could be replaced with a mock. And then, if you're familiar with mocks, I'll just show a quick example. But if you're familiar with mocks, what we could do is that we're not changing the API for the function, and what we're doing is that we're setting an expectation that the post function is called, and in that expectation we send the message, right? And then we execute to the process, to the test process. And in that function, in the expectation, then in the test, sorry, we call the background work function, and then we use assert receive again. And the nice thing about this, the much nicer thing about this, I think, is that everything is localized in the test process. Everything is scoped to the test. So it's a test that's actually, you don't pass PIDs around, you don't pass refs around. The background work function doesn't know anything about PIDs and refs. Everything is done in the test. You could change the implementation of, instead of passing a ref, you could pass something else. Instead of, you could change the message, and everything would be scoped only to the test. It's not anymore a contract between the test and the code, but it's just a contract in the test by itself, right? So these are good techniques. So background work, when it comes to like background work like this, is kind of the easiest one to test, I feel like. If you don't have, there's other ways you can test I/O and stuff like that through messages. So all those things tend to work pretty well. One thing that's really hard to test in my experience is periodic actions. So by periodic actions, I mean when you have something that's like ticking and doing something every time interval, and that's really hard to test because it's a thing that's running in your application, and it's really hard to whenever time's involved. Really, it's pretty hard, right? So imagine this is a really trivial piece of code. It's just we have a weather checker thing. It's like a gen server that every 5 seconds checks the weather and does whatever, right? And like a pretty straightforward way to implement this is you have this function timer send interval built into Erlang that sends a message in this case, every 5 seconds to the PID that you specify. And in this case, we're handling, so we send a tick message and we handle the tick message by checking the weather. So this is pretty hard to test. It's not trivial, especially written like this, right? Because imagine that we can check if the weather we can assert if the weather was checked. We have this weather checked function, returns true if the weather was checked. So we can talk about the testing and not about the implementation. But if we have this, like, what do? We have to resort to some stuff like this process sleep thing, right? Because we start the weather checker, and that thing's going to just start to, like, every 5 seconds it's going to start checking the time, right? So how do we make sure that checking the weather? Sorry. So how do we make sure that that check happens? Like, it's not trivial. You can do some kind of pretty ugly hacks, like this process sleep thing. We're basically saying, okay, the interval is 5 seconds. Okay, let's multiply it by 1.5, and so probably this thing would have checked the weather after 7.5 seconds. But it's a pretty brittle test, as you can imagine, right? And 5 seconds is a long time. Imagine if this was doing these checks every 2 or 3 milliseconds, right? There's a big chance that, like, the weather would be checked twice, or the weather would be not checked yet, and it's really hard to assert that this has not been done the right number of times. It's pretty prone to race conditions. So in these cases, my go-to thing, these are really hard to test. So it's never going to be pretty in my experience. One of the things I like to do is to abstract the tick. So you abstract the ticking part. In this case, it's the weather checking, and you make it triggerable in multiple ways through an API, for example. And in this case, imagine that our weather checker becomes like this. So you still do the send interval every 5 seconds, but you also have another way, this def tick function. You have another way to trigger the weather checking, right? So that you can test that the gen server knows how to check the weather. And then the test for this becomes, we just triggered the tick manually, and we assert that the weather was checked. And what this is doing is basically the only part of this gen server now that is not tested is the periodic action, but the actual action that's happening every interval is being tested, right? Now the part that we're not testing is that this thing does it at an interval, right? And that's really, really hard. And another problem here is that this thing is still running in the background other than being ticked by us, right? So if the interval is really short, it could still get triggered in the background, so that's really hard. A really bad way of fixing, not bad, but like a really dirty but efficient way of isolating this at least, is that you have different modes of operation, or you have like an interval mode and a manual mode, and you start this resource in manual mode in tests, so that you have control over the behavior, and it doesn't do this thing at an interval. And again, you're able to freely and pretty easily test the behavior of checking the weather then, but you're not still really testing the fact that it does it as at an interval, right? And to do that, I haven't really found like a good way to do it. Some people use test doubles for the time, so that you know how many times you don't use send interval, but you use an abstract interface over ticking the gen server, so that you have control over how the gen server gets ticked. But that becomes very, very like specific to use cases, and in general it's really hard. But with this approach, at least you get to a place where you're testing the behavior that happens at an interval, but even if you're not testing the interval. So if you keep the functionality of doing things at an interval small, hopefully no bad things happen. This is very tight. The next thing is very, very tight to this, which is that usually the problem with even bigger problem with this process is that it's pretty rare that you start a process like this on demand in your application. Usually what you're going to have is you're going to have this process in the background running. You start it when you start your application, it's just going to run in the background, right? You start it in the supervision tree of your application, and that's generally a singleton is what I've heard it called. So it's a singleton is basically a unique resource in your application. So if you imagine in your application, usually the resources that you have are multiple. So if you imagine a Phoenix application, you have every request comes with a different process, and usually you start resources on demand to do things when a request comes in. But if you have things that are unique in your application, like something that's in the background, a process that's in the background running checks on the weather, for example, that would be a singleton, right? So it's not spawned on demand, but it's a fixed part of your application and a unique part of your application. And this becomes really easy to test, especially because imagine that this is doing the work in the background, then it's running throughout the life cycle of your test suite, right? It's just running in the background. So how do you test that? And it's really, really hard. An idea here is to just don't start it in tests if you can. So like a trick that you can use is you can have different supervision trees for tests and production. This is definitely not pretty, but I've been guilty of doing it, and it kind of does the job, gets the job done. So you have at least your test suite is okay, and you can test the weather checker thing in isolation instead of during the application lifecycle. But otherwise, it gets pretty hard, and the only tools you have at your disposal really are mocks, in my opinion, are mocks and test tables, and in general, where you can do it. You can kind of control what this weather checker thing is doing, so that in your application during the life cycle of the test suite, it's not going and doing crazy stuff, but it's actually, you control what it's doing. But in general, the thing in all these cases is that you need to modify the singleton resource in order to accommodate for tests, usually. So you need to not make it check the weather, or not start it, or do something for tests, so that it's easier to test that. That's just hard. So, and when it comes to this kind of testing for things that are hard to test, testing resilience is one of the hardest thing, I think. And especially when testing resilience is, I think and by resiliency I mean, how do we test failures, right? How do we test how our system reacts to failures, and especially crashes, right, which are kind of unexpected failures. And here I really like to get philosophical for a second, because when I hear people say, but how do I test if this process, what happens if this process crashes? Then I really like to go back to what does it mean for a process to crash, and what does it mean to the Erlang slogan, let it crash. So when a process crashes, it's usually because in my opinion, it should be because something really unexpected happens, right? But then if I put it like that, if something unexpected happens, how do I test for it if I don't expect it, right? It shouldn't happen. If I expect it, then I should probably handle it, and then testing becomes like testing something expected, right? But if a process is crashing because of something unexpected, by definition, I don't expect it, so I don't even know how to test it, right? So what can we test about it and about these process crashes? I think probably the only thing that I found worth testing in these cases is if you have processes that when they crash, there's some cleanup that absolutely needs to happen. So for example, I don't know, files need to be deleted, otherwise you get a disk memory leak, something like this, right? If something absolutely needs to be cleaned up, then maybe this is one of the possible things worth testing about failures. And in this case, a test could look something like this. You have a test where you actually start a process that you're testing the behavior under failure, and then you kill it, and then you assert that the cleanup was successful. This is the kind of test that I would write. It's not easy to write because processes that crash don't get a chance to clean up. So in general, your application code needs to deal with that. So you have to have, for example, external processes that monitor your processes and make sure that the proper cleanup happens. If you have a process that uses a file and you want to make sure that gets deleted, for example, you can't do it in a terminate callback or anything like that. You need to have another process, because if the process crashes, then it's not going to be cleaned up, right? So you have to have additional logic to clean that up, and then it becomes easier to test when there's that around, right? But in my opinion, in the philosophical approach to this, I think this is maybe one of the few things that are worth testing about crashes, because again, if they're unexpected, if they're expected, I would actually handle them. So that's where I disagree with let it crash taken as just write the happy path, right? If a TCP connection breaks, that's not unexpected. That's going to happen, right? So letting it crash is not going to help. It's just going to make it harder to debug, harder to recover from, harder to test, and so on and so on. So. And when it comes to process crashing and general failure in OTP, we can't really not talk about supervision trees. And testing supervision trees is one of the things that I've never, ever done personally. So I would love to defend this stance and how I test supervision trees. I get this question quite a lot because obviously you're writing code. Supervision trees are code. You want to test that they look the right way. You want to test that they behave the right way. In my experience, it's really hard to test that. So what I usually do is when I'm building supervision trees, I try to do some exploratory manual testing. So basically you go into the observer or on the shell and you start killing processes and see what happens. And in my experience, supervision trees are not even something that change so often. So once you get an idea that things are working, also you don't want to test the OTP itself, right? You know that the behavior is right. The thing that you would want to test is that you're shaping your supervision tree and you're architecting your supervision tree correctly. But I've always found it hard to test it in an automated way, right? There is an interesting tool that I want to mention called SUPS, which is basically property-based testing applied to supervision trees. You can find it under Fred Herbert's GitHub, and it's basically a tool that just simulates failures in parts of the system in a property-based testing approach, and just shuts down processes around them in your application. And you have to write tests to make sure that your application is still behaving in an expected way when that happens. But I've never personally used it because I've never felt such a strong need to test the system under failure, right? Usually this is something I would reserve for systems that cannot allow themselves, like, afford failures, right? Which is not usually the systems that I'm writing. So yeah, that's so conclusion. Let's see. Testing hard things is hard. This is my conclusion after this, is that it's really hard to test these things because there are hard things to there's a lot of moving pieces. There's a lot of concurrency, of parallelism, of things that can fail, of shared resources. Whenever there's all of that, it's really hard to apply good testing principles, such as isolating tests and making them reproducible, making them fast, and just having control over them. It's hard, but at the end of the day, why do we test? We test because we want to have confidence in our code base, right? So the ultimate goal of the test suite is to give you confidence over your code base and to make sure that you have a level of confidence where you can make changes, and if no tests break, you feel good that your changes are not breaking something. So you want to kind of keep regressions out of your changes, and you want to have confidence that things work as expected. So that's the ultimate goal. And yes, your test suite is part of your code base, and so it pays off to treat it well and to apply good practices and to make sure that it runs fast and in isolation, and that it fails if something is if something is broken, and that it doesn't fail if nothing is broken. But ultimately, it's there to give you confidence over your code base. So my number one goal is that when I write tests, is that I need to have confidence over my code base. So I need the test to break if something is wrong. Everything else is secondary, right? So I will sometimes go to extreme lengths to like inspect inspect the states, and or for example create mocks for the system module so that I can try really weird things out with exit signals or stuff like that. But the ultimate goal is that I want to make sure that the tests break if I break something in my code, right? But I will not go to all the possible lengths in the world, because sorry, I'll skip this slide, which was that a dirty test is better than no test in my experience, right? So I'm open to doing dirty things to test to have effective tests, and if you have no other choice, I will always go for tests rather than no tests if it's doable. But I will not go to extreme lengths to do testing, and this is something I really believe in, because sometimes I feel like we are trying to test in an automated way too much, and we forget that the world of testing is bigger than automated testing. So automated testing is a small part, and this kind of refers back to what I was talking about with supervision trees, that automated testing is not the only way to test things, right? There's production testing, there's QAs, there's manual testing, there's a million things you can do there you go. There's a million things you can do to test things that are not necessarily automated and not necessarily reproducible by a computer, but sometimes the lengths you have to go to in order to automate some types of testing are never going to pay off, right? If you spend 3 months writing tests for a piece for a supervision tree, when you're going to test it once a month for 1 hour for the 5 years that your product's going to be living, then it's probably worth to just put the 1 hour a month for 5 years, right? Rather than spending 3 months to test it. So I'm a big fan of QA. I'm a big fan of production testing. I do all of that, and it keeps the code, the test suites simple enough, and it still gives you confidence over your code base, which is ultimately what you want from testing, right? So that's my pitch: is that if it's really getting crazy, then like other ways to test it are also fine. That's all, I think.